Hello students, in this lecture we'll continue with an example of a control system and we'll plot a Bode diagram. Now this lecture is in continuation with lecture number 22, that is frequency response analysis. Now the example over here is we have given a control system where the control system is represented by the following block diagram. That is, we have a controller, that is PD controller, and a process consisting of 3 tanks in series whose transfer function, the overall transfer function, is represented by this transfer function, and that's R, and we have a measuring element with a lag of 0.1, this thing. Clear? So we need to plot a Bode diagram for this. Now remember this, when we talk about frequency response analysis, we always talk about open loop transfer functions. So the open loop transfer function for this particular system is will multiply all the transfer functions, that is K1 plus tau ds into the transfer function of the process, that is s plus 1 whole square into 0.1 s plus 1 into e minus 0.1 s. Now for value of kc equal to 10 and tau d equal to 0.5, we can write down the overall open loop transfer function as 10 into 1 plus 0.5s into e minus 0.1s over s plus 1 whole square into 0.1 s plus 1. Clear? Now that's the overall open loop transfer function we have. Clear? Now we can find out the amplitude ratio and we can find out the overall phase angle for this particular system. Now let me write down the transfer function again over here, that is 10 into 1 plus 0.5s into e minus 0.1s upon s plus 1 whole square into 0.1 s plus 1. Clear? Now what we can do is, we can, for overall amplitude ratio, we can divide the transfer function separately. That is, we can take this transfer function as one single transfer function, this can be taken as a separate 1 upon this can be separated, and this can be separated. So for, let's say, let's name it as G1. G1 is 10 1 plus 0.5s plus 1. G2 can be taken as e minus 0.1s. G3 can be taken as 1 upon s plus 1 whole square, and G4 can be taken as 1 upon 0.1 s plus 1. Then the overall amplitude ratio will be nothing but AR of 1 into AR of 2 into AR of 3 into AR of 4. Now let's find out the ARs, amplitude ratio of individuals. AR1, it's a PD controller, so AR1 can be taken as 10 under root of 1 plus 0.5 omega whole square. Clear? AR2, it's a lag, so AR2 is always 1. Amplitude ratio 3. Now this is basically the square of first order, so we can write for first order and then we can multiply again with the first order, so it becomes first order whole square. So amplitude ratio of first order is 1 upon under root of tau square. Tau is 1, omega square plus 1, and since it's square, so we write it down square, so it is 1 upon nothing but omega square plus 1. That is the amplitude ratio of the third. Amplitude ratio of the fourth, 1 upon 0.1 s plus 1, first order, so 1 upon under root of tau. Tau is 0.1 omega whole square plus 1. So we have individual amplitude ratios now. So overall amplitude ratio will be nothing but this multiplied by the amplitude ratio second, multiplied by the third, and amplitude ratio multiplied by the fourth. So that is the overall. Now let's plot the individual amplitude ratios. For individual amplitude ratio, I have this log graph paper with me, where on the that's the amplitude ratio, and we have the frequency versus over here. Now let me put the values. Let's say the minimum is 0.1, 1, 10, 100 and 1000, and somewhere here, okay, let me change this value. This is 0.01, this is 0.1, 1, 10, and we have 100. Similarly on the y-axis also, on the x-axis also, let me change the values differently, because it's easy to keep the values on both the axes same. So 0.01, this will be 0.1, 1, 10 and 100. Clear? Now we're gonna, in this Bode plot, we're gonna plot the amplitude ratio versus frequency for the individual graphs, as well as we're gonna plot it for the overall. Clear? Now for the individual, now if you see AR 10 equal to this thing, so what I do is I can rewrite this thing as AR by 10 equal to under root of this. That will be easy, because then I can represent it over here. Now for AR equal to, now for different values, okay, now how to plot this thing? In order to plot, what I do is I make a table, and then I can write AR1, AR2, AR3, I can write AR4 and AR overall, and over here omega versus frequency. Now how many values I've taken? 0.1, 1, 10. Okay, so I can take 0.01, I can take 0.1, 1, 10, and at the most maximum 100, right? And 100. Now for AR1 by 10, AR by 10, and obviously the overall will also be by 10 because it gets multiplied. So for 0.1, if you put 0.1 over here, I'll have one value over here. So calculate all these values correspondingly for different values of omega tau, and then the overall will be nothing but the multiple of all these values. So you'll have these values over here. Now, or if you do not want to plot the actual plot, it's very simple. Now for first is for PI controller. For PI controller, I know the exact shape. Now what will be the corner frequency? Okay, corner frequency of this, corner frequency will be 1 by tau. Tau is 0.5, so 1 by 0.5 is corner frequency is 2. So that means for low frequency it is 1. So that means it continues till 1, it goes 1, it could continue till this value, and then it will go in the upward direction. Now this is the corner frequency of equal to 2. So this is your PI controller, that is for AR for G1, that is for this value, for this particular transfer function. That's the Bode plot. Second, AR is equal to 1, so that means for lag, for any value of omega frequency, AR is 1, so it is represented by this red line, so it remains a straight line, so that is G2. Clear? Third system, it's a first order system with the slope of -2, So for different values of omega, it is this. Also, the corner frequency in this, the corner frequency is 1 by tau. Tau is 1, so corner frequency is 1. That means it will turn at 1. So now I'll plot it by the green line. So it will continue till 1 at lower value, and then when it reaches 1, it will move downwards. That is G3 with a slope of -2. Clear? So you can, what you can do is, slope of -2 means tan inverse of -2, whatever the angle. So you put the d over here and you plot this angle. Then fourth one, AR, this thing, first order. Now what's the corner frequency of this? 1 by tau. 1 by tau is 0.1, that is 10. So low frequency, high frequency meet at 10. So somewhere here it is this. So I'll represent it by the blue line. So this will continue at 1, 1, 1. Once it reaches 10, it moves downward. So that is G4 with a slope of -1. Clear? Now these are the individual plots. Once you plot the overall, so for overall what you need to do is, from this table corresponding to these values, you have these values. So you point it out somewhere here. Let me use some different color. Okay, I'll use this one. So somewhere here I have one value, somewhere here I have another value, somewhere here another value, and another value, and then you can join this thing. So this is basically your overall plot. Clear? So overall plot will be represented by overall plot. That is for G open loop transfer function. So that's how you plot the individual Bode plot and the overall Bode plot. Now there is one more important term which I forgot to tell over here. Now that is the amplitude ratio. Amplitude ratio is represented by decibels. Basically the values of the amplitude is presented in decibels. So you remember this, that 1 decibel is equal to 20 log to the base 10 of amplitude ratio. So if AR is 1, so it means 0 decibels, and if AR is 0.1, it means -20 decibels. So remember this thing, the units of amplitude ratio is in decibels. So that means in industry, if you come across such Bode plots, here these units can be converted into decibel graphs. So like somewhere here on the axis you can have -200, -20, 1, and so on. Clear? They'll be given in decibels. So this is how you can plot the Bode diagram for any given control system. The only method is, you first you can identify into separate standard transfer functions, like in this case which I've done, and then you can multiply the then you can find out the amplitude ratios and the corresponding corner frequencies, and then for overall amplitude ratio it's nothing but the product of individual amplitude ratios. Now this is, I have done it by using high frequency and low frequency asymptotes, that is asymptotic curves. You can also plot using the actual values. So if you have these values corresponding to like 0.1, 1, 10 and 100, you have these specific values. You can also plot these values on this graph paper and you can have the similar shape. So this is how you plot the Bode diagram for any given system. If you have any query related to how to plot Bode diagram, you can contact me. Thank you so much.